In today's video, I will be going to cover a topic, degree of static indeterminacy, and also this is the continuation of my last uploaded video. So here today I will be discussing the degree of static indeterminacy in case of the beam. So in case of beam, so we have a formula for finding the degree of static indeterminacy for beam, that is ds is equal to dse plus dsi. So where ds is equal to degree of static indeterminacy and dse is equal to external static indeterminacy, and dsi is equal to internal static indeterminacy. So particularly in case of the beam, the dsi is equal to 0. So always remember this. For finding the static indeterminacy in case of the beam, dsi is equal to 0. So our equations becomes ds is equal to dse. Now we have a formula for finding dse. dse is equal to r minus e minus a. Okay, so where r is equal to number of unknown reactions and e is equal to number of equation of equilibrium, and a is the number of additional equilibrium conditions due to internal hinge. Okay, so now I'll tell you what is this a. Suppose, and before that I'll let you know the formula for finding the a value. So a is m dash minus 1. From this equation we can find the value for a. So now m dash is equal to number of members connected to the internal hinge. Okay, so I'll give the example. I'll show you the example for this. Now suppose this is a beam, okay, and here one internal hinge is present. So how to find a? We know that a is equal to m dash minus 1. So here m dash means number of members connected to this internal hinge. So for this case, how many members are connected with this hinge? From this one member, and from this side is 2 member. So there are 2 members which is connected with this particular hinge. So the value for m dash will be 1 and 2. 2 minus 1, that is 1. So here the value of a will be 1. Now again I'll give the example, another example, that is here. Okay, so this is a beam where 2 internal hinges are connected. Okay, so if 2 hinges are connected, that means how we have to calculate this one? We have a formula for a is m dash minus 1. So there is 2 hinge here. So what we have to do, we'll consider this hinge as A1 and this hinge as A2. 2. Okay, so now for A1 we have a formula m dash minus 1, and m dash is nothing but number of members connected with this particular hinge. So now we are finding for the A1, so we have to see only for this case. Okay, so for this case 2 members are connected with this hinge, so m dash value will be 2 minus 1, it will be 1. Now again we have to find for this case A2 is equal to, again we have a same formula, that is m dash minus 1 is equal to m dash, again number of members connected to this hinge. Again there is a 2 members connected to this hinge, so the value of m dash will be 2 minus 1, it will be 1. Okay, so now what we have to do is A will be A1 plus A2. So we have a value for A1, that is 1, as well as for the A2, that is also 1. So 1 plus 1, it will be 2. So the value of A in this types of beam is 2, and for this types of beam is 1. Okay, so likewise we have to find the value of A. Now I'll show you, I'll solve one problem for finding the degree of static indeterminacy in case of the beam. Okay, these are the examples. So now suppose it's a beam and both the ends are supported, it's a hinge support. Okay, so now here 2 internal hinges are also present, and we have to find the degree of static static indeterminacy here. So we have a formula for ds is equal to dse. Okay, so this is the formula for finding the static indeterminacy for beams. So now we also know that dse is equal to r minus e minus a. We have this formula with us. Now r is equal to number of unknown reactions. So here both ends are hinge support, right? So number of unknown reaction in case of the hinge is 2, that is vertical and horizontal. Here also it will be like this only. Okay, so total number of unknown reaction here is 1, 2, 3 and 4. Okay, 4 number of unknown reactions are present, and E is the number of equilibrium equations. So we know that it's a 3. And here in this case what happened, we have 2 internal hinge. So as I already told you how to find the A value here, this value. So we'll consider this as A1 and this as A2. So here A1 is equal to m dash minus 1. Here the number of members connected with this hinge is 1 and 2. So it will be 2 minus 1 is equal to 1. Again we have to find for the E2. It will be same. Here also 2 members are connected with this hinge. So it will be 2 minus 1 is equal to 1. So the capital A value will be A1 plus A2 is equal to 1 plus 1 is equal to 2. So now we have a value for R, E as well as for the A. So what we have to do is we have to put all the values in this formula. Okay, so now DSE is equal to R minus E minus A. So we have a value for R here, that is 4, and E is 3, minus A is 2. So the value for DSE is minus 1. So we know that ds is equal to dse. So we have a value for ds is equal to dse value is minus 1. So we can say that the degree of static indeterminacy for this type of beam is minus 1. Okay, so now again I'll take one more example. Here, suppose it's a beam and this is a hinge support and another end it's a roller support, and in this type of beam there is no internal hinge present. So we know that here for the hinge support we have two unknown reaction, and in the roller support there is only one reaction, and here also we have to find ds. Okay, now again we have a formula for ds is equal to dse. dse is equal to r minus e minus a. Okay, our main motive is to find the ds value here. So here number of r is equal to number of unknown reactions 1, 2 and 3, and e is equal to, we know that the equation of equilibrium, that is nothing but 3, and a, here see in this beam there is no hinge inside, so the value of a will be 0. So now what we have to do is we have to put all the values in this equation, that is ds is equal to r is 3 minus 0, so dse is equal to 0, therefore ds is equal to dse, so the value of ds will be 0. So for this type of beams the static indeterminacy is 0. Okay, again one more example I'll show you, that is one side is fixed and the other side is hinge support. Okay, and here also there is no internal hinge, so here also we have to find the ds. So now we have a formula for ds is equal to dse, and dse is equal to r minus e minus a. So for this type of beam, this beam is one side is fixed and the other side is hinge. So for a fixed support what happened, we have three unknown reaction, that is vertical, horizontal and the moment, and for the hinge support there is two unknown reaction, that is vertical and the horizontal. So now for this case the total number of unknown reaction is 1, 2, 3, 4 and 5. Okay, 5, and e is the number of equation of equilibrium, that is 3, and a is not present in this case, so a will be 0. Now just we need to put all the values in this formula, that is 5 minus 3 minus 0, so it's comes out to be 2. So ds is equal to dse is equal to, we have a value for dse, that is 2. So for this type of beam the static degree of static indeterminacy is 2. Okay, so these are some of the example for the degree of static indeterminacy, and in my next video I will be discussing about the degree of static indeterminacy in case of plane truss. Okay, plane truss. Thank you.